Hi student, welcome back to chemistry class with Odisoro Lekon Adiola. This video is brought to you by Igotha Virtual Learning, and in this video we are going to be looking at the other separation methods. We have started with the other separation methods as discussed, but in this video we are going to be looking at the separating the homogeneous mixture. The one we have looked at in the last video was heterogeneous mixtures, where we look at the solid liquid heterogeneous mixtures and how we can separate them using decantation, centrifugation, filtration. We also looked at the precipitation method. We looked at flotation. We looked at heterogeneous liquid-liquid mixture, which are separatory funnel method. We solvent extraction. We also look at solid heterogeneous mixture, that's use of magnetic separation. We looked at sieving, sublimation, and some questions. In today's video, we are going to be looking at homogeneous mixture. We have been able to define homogeneous mixture in the previous video. So we look at solid liquid mixture, solid liquid homogeneous mixture. In solid liquid homogeneous mixtures, we have evaporation, and that's what we're looking at salty water. A typical example is separation of salt and water. Evaporation is a type of vaporization that occurs on the surface of liquid as it changes into the gas phase. The separation technique can be used to separate solutes that are dissolved in solvent by boiling the solution. The solvent gets evaporated, leaving the solute behind. But there are key factors that affect evaporation. Number one, the concentration of the substance evaporating in the air, the flow rate of air pressure, temperature, the surface area, and the intermolecular forces. There are key procedures to evaporating a solution. Let's take for instance you have a salt water solution. You pour the solution into an evaporating dish. You heat the solution to dryness to evaporate the solvent away, leaving the solute behind. So these are major procedure for evaporating a solution. You can even try it at home. Get a salt, dissolve it in water, pour the solution into a pot, heat it until the water evaporates. You will find your salt behind after. Okay, so what are the application of evaporation? Evaporation can be used in drying wet clothes, drying air with air dryer, and obtaining common salt from the sea. The second one for solid liquid homogeneous mixture is crystallization. Crystallization is used to separate dissolved solid from the liquid by evaporating the liquid. It is used to separate dissolved solid from the liquid by evaporating the liquid. In crystallization, crystals are usually formed. Please take note that the method for obtaining the purest form of solid is crystallization. If you want to have the purest form of solid, crystallization. What are the process? You pour the solution into evaporating dish. You heat the solution to evaporate away the solvent until some solids start to appear or a saturated solution is obtained. You allow the solution to cool. On cooling, the crystals of the solid that can no longer dissolve in the solution will be deposited. Then you filter the mixture to collect the crystals, which should be the residue. So these are the process of crystallization. Impure solid is dissolved in a solvent. The solution is heated to evaporate most of the solvent. The hot solution is allowed to cool. The solid appears as pure crystals. Then the cold solution is poured off to obtain the crystals. And then, of course, this is an example of salt extracted from seawater and is obtained by crystallization. You can also obtain sugar. sugar production also uses crystallization method. In fact, most drug production also uses crystallization method because crystallization is used to obtain the purest form of solids. You can try this at home by making a sugar crystals that you can eat. You prepare a saturated sugar solution by heating it. Use some color from food coloring and then keep it for a few days to evaporate. Then you can enjoy your sugar crystals. And then the next one for solid liquid homogeneous mixture is chromatography. Chromatography is a separation technique used to separate different components in a liquid mixture. Uh, Chromatography employs the principle of the rate of movement of substances over an absorbent medium. The rate of movement of substances over an absorbent medium. The mixture is dissolved in a fluid called the mobile phase, which carries it through a structure holding another material called the stationary phase. Then chromatography is a vast separation technique that have many methods or has different principles of separation involved. Uh, Actually, we can have what is called the paper chromatography. We have the thin layer chromatography. We have the gas chromatography. You have liquid gas chromatography. You have HPLC, that is high performance liquid chromatography, and so on. But basically for this level, we look at paper chromatography more. So in a chromatography setup, the mixture is dissolved in a solvent called the mobile phase. You can see it there. You can see the mobile phase, either water or any other solvent. It's dissolved in a solvent called the mobile phase, which carries through a system, a column, or capillary tube, or a plate. If it is a column, you are dealing with column chromatography. If it's a sheet, you are dealing with paper chromatography, on which a material, the stationary phase is fixed. Because the different constituent of the mixture tends to have different affinity for the stationary state, they are retained for different lengths of time. And as such, the separation is based on different partitioning between the mobile phase and the stationary phase. You can see the processes here. Separation of black ink, for instance. You have a closed jar of water. The strip is dipped inside that closed into the water, and then as the water rises up, uh, uh, it takes the dyes along with it, and you can see that they start to separate into their different components based on the movement uh, of colors, or based on their rate of movement over the absorbent medium. um, uh, Chromatography has to do with any color substances, even the pigment, the pigment, the chlorophyll, which is a green pigment in plant, can also be separated using chromatography method. Now let's go to the liquid homogeneous mixture. For instance, you can have crude oil, you can have water and alcohol, or ethanol. For instance, in liquid mixture, you have distillation. Distillation is used to separate homogeneous mixture by conversion of a liquid into vapor, which is then condensed back. In distillation is a separation technique used to separate two miscible liquid. Please take note. It is used to separate two miscible liquid using the differences in their boiling point. Distillation is used to separate two miscible liquids using differences in their boiling points. Now, if they have a close range of boiling points, we use fractional distillation. If you have a wide range of boiling points, you use simple distillation. Please take note that distillation is used to obtain the purest form of liquids. For the purest form of solids we use crystallization. The purest form of liquids we use distillation. So we have two types of distillation. Like I've said, simple distillation is a method used to separate two miscible liquid of wide range of boiling point. An example is separating ethanol or alcohol and water. Ethanol has 78 degrees Celsius as its boiling point, while water is 100 degrees. So the difference between them is approximately 22 degrees. So it is still wide. In a simple distillation setup, you have your round bottom flask, you have the mixture in that round bottom flask. It is being heated, and then of course, after being heated, it forms a vapor. Once it forms a vapor, the vapor is made to pass through what is called a Leslie condenser, which condenses the vapor back to liquid. It condenses the vapor back to liquid. And then of course, from there, you can have your distillate. So this is a method, this is the simple distillation methods, and it is applicable in a chemical laboratory. Then you also have the fractional distillation. Uh, Fractional distillation is similar to simple distillation, but the difference is that fractional distillation is used to separate two miscible liquids of close range of boiling points. And a typical example for that is the fractional distillation of crude oil, and also the fractional distillation of liquefied air used to prepare nitrogen and oxygen. Um, so in a simple fractional distillation process, the mixtures are also heated. Mixtures of crude oil are heated, and they form into fraction in a fractionating column. Fractional distillation uses a fractionating column, and as a result, each of the fractions of crude oil separate into different trays in the fractionating column. You observe that the boiling points are close, and of course they separate into their fractions. So what are the industrial application of fractional distillation? Oil refinery, to separate the various components of crude oil, like we have said. uh, it is used in industry to supply oxygen to hospital because it separates different components of air. It is also used to in the industrial preparation of oxygen and nitrogen. In industrial preparation of oxygen and nitrogen. So these are separation method for homogeneous mixture: solid, liquid, and liquid. For solid liquid, we have talked about um, evaporation, crystallization, and chromatography. And for liquid, we have talked about simple distillation and fractional distillation. Now let's look at test for purity. How do we test for the purity of substances? Actually, we do not have many pure substances in nature. Most substances occurs in combination with other substances as impure substance. So to test for purity of substances, we use melting point for solids, boiling point for liquids, melting and density for solids and liquids, then chromatography for color substances. To test for a solid substance, for example, if the melting point is at a fixed temperature, if you have a definite melting point, that means the solid is pure. If it has a definite uh, boiling point, that means the liquid is also pure. If it has density, a fixed density, that means both solid and liquid are pure. And then if it shows only one spot in the chromatogram, that means the color substance is also pure. So these are methods by which you test for purity of substances. Then quickly let's look at some WAEC question. WAEC 2016 say you have to explain briefly the following separation techniques: crystallization, evaporation, and filtration. Now, I have explained. You can go back to the previous slides and look at the explanation. But in this process, WAEC is expecting the following. When you are discussing or explaining crystallization, you must note that the heat, you must heat or concentrate the solution. That's the first step. It must be there. You must cool then after you obtain crystals. So in explaining the process, concentrate the solution, cool, and obtain crystals are key indicators that you are going to get it right. Those are the key information WAEC needs. Secondly, when you are discussing evaporation, you heat the solution escape into the air, then the required solute is left behind. And then for filtration, you are expected to pour the solution into a filter paper. The liquid pass through as filtrate, while the solid remains on the filter paper as residue. These are key information WAEC is expecting to answer that question. So go back to the next slide and use this information I've provided here to coin how you are going to explain crystallization, evaporation, and filtration. The second question is an objective question, WAEC 2011, and then the question said, which of the following separation techniques would show that black ink is a mixture of chemical compounds? Like I've told you, any um this is an example of the black fluid identifier. Anything that has to do with color substances uses chromatography. Therefore, the answer is B. So far we have looked at test for purity. We have looked at separation of homogeneous mixtures, both solid liquids and liquids. So do well to revise these topics again, and of course answer as many questions as possible on separation techniques. Continue to learn chemistry, and bye bye.